Section 2.8 is on solving quadratic equations using the square root property and the quadratic formula. In part A, we're going to look at the square root property. The quadratic formula will be in part B. We already know one way to solve a quadratic equation, and that way is factoring. We're going to look at factoring to solve the equation x squared minus 16. So don't forget that this factors as a difference of squares. It's going to factor into x plus 4 times x minus 4 equals 0. Then you can solve each piece by setting it equal to 0. X plus 4 equals 0. X minus 4 equals 0. So subtracting 4 from both sides gives you x equals negative 4 in the first. And adding 4 to both sides gives you x equals positive 4 in the second. So you should get the two answers, x equals negative 4 and x equals positive 4. In this section, we're going to look at a new method for solving equations of this form. This new method is called the square root method. And the square root method is going to have you, instead of getting an equation equal to 0, it's going to have you isolate the perfect square. Be sure the other side has only numbers, no variables. Then take the square root of both sides and solve from there, making sure when you take the square root of both sides that you include both the positive and negative square roots. So, same equation from before, x squared minus 16, but we're going to solve it using this new technique. First, isolate the square root, the perfect square, so you're going to add your 16 to both sides. That's going to give you x squared equals 16. 0 plus 16 is 16. Then take the square root of both sides. When I take the square root of x squared, that's going to give me just x. Right here, I'm making sure I write square root of x squared is x, making sure I write both plus and minus on the non-variable side when I take the square root. So I'm going to have x equals both positive and negative. The square root of 16 is 4. Remember that I was going to get two answers from this original equation, negative 4 and 4. I need to make sure I get both answers, both the positive and the negative, when I use the square root method also. If I don't write plus and minus, I only have one answer when there should be two. So it's very important to remember to write the plus and minus when I solve using the square root method. Okay. We've got some more examples on the back of this page. Let's flip. The square root property or square root method says that the equation x squared equals k has two solutions. X equals plus and minus square root of k. When you take the square root of both sides, the square root of k is square root of k. So I want to solve x squared equals 9. So square root of both sides, x equals plus and minus square root of 9, which of course is 3. So I get plus and minus 3. Two answers. The equation x squared equals 9 has two solutions, 3 and negative 3. Recall that the square root of 9 is the one number 3, so it's essential, since square root of 9 is just one number, that in front of the square root, when you solve, you write the plus and minus, giving you your two solutions. Okay, so a few more examples. I want to solve x squared equals 7, so if we take the square root of both sides, that's going to give me x equals plus and minus the square root of 7. Can't simplify that, so that's done. In part B, I can't take the square root until the perfect square is by itself, so you have to add your 50 first. So r squared equals 50, take the square root of both sides. It's going to give you r equals plus and minus the square root of 50. Now, unlike the 9 or the 7, I can't do the square root of 50, but I can simplify it. So I've got plus and minus the square root of 50 can be broken down into square root of 25 times square root of 2. So I get plus and minus the square root of 25 is 5 times the square root of 2. Two more on this page. Next, another one that I need to solve for the perfect square first. We need to subtract the 5 first. So I've got 80 minus 5, so I'm going to have 3x squared equals 75, and then divide by 3 on both sides gives me x squared equals 25. Square root of both sides to solve, x equals plus and minus the square root of 25, which gives me 5. Okay, in part B, I have an entire group squared. So the perfect square here is the square of 2x minus 1. That perfect square is already by itself. So I am ready to do the square root of both sides. So I'm going to have 2x minus 1 equals plus and minus the square root of 49, but the square root of 49 is 7. Because I got a whole number here, I'm going to be able to add 1 to both sides, but adding 1 to positive 7 and adding 1 to negative 7 gives me different results. So I want to separate this into 2x minus 1 equals 7 and 2x minus 1 equals negative 7 so that I can add 1 to both sides and continue to simplify. 2x is going to be equal to 8. Divide by 2, divide by 2. That first one's going to be x equals 4. Or 2x is going to be equal to negative 6. Negative 7 plus 1 is negative 6. Divide by 2 gives me x equals negative 3. Okay. So I had to separate that one and solve because there was more work to do once I took the square root. Okay, so if I look at the last page for part A here, or actually my pages might be stuck together. Yeah, actually more than one page. I just had my pages stuck together. Okay, so example 4. My perfect square is not by itself in 8n squared equals 3, so I would divide by 8 on both sides first. So it gives me n squared equals 3/8, and then I would take the square root of both sides. So, I already did the square root, so I don't have n squared anymore, I just have n, equals plus and minus the square root of 3/8. I can't leave it as 3/8 because a fraction is inside the square root, and particularly I have a square in the denominator, so I need to rationalize this one. So I'm going to multiply by square root of 2 because I know that 8 goes into 16 as the smallest perfect square. So n is going to equal plus and minus the square root of 6 over the square root of 8 times 2 is 16 equals plus and minus the square root of 6 over 4. And again, that's simplified because there's not a fraction inside the square root and because there is no radical in the denominator. Next, we have another one that has a binomial perfect square. I still need to get it by itself first, so I need to add my 8. So it's going to give me 2 times x plus 3 squared equals 108. Then I need to divide off the 2. So this gives me x plus 3 squared equals 54. Okay, so take the square root of both sides now. That's going to give me x plus 3 equals plus and minus the square root of 54. Now 54 is not a perfect square, but can be broken down into square root of 9 and square root of 6. So x plus 3 equals plus and minus the square root of 9 times the square root of 6. I'm writing a little bit smaller here. X plus 3 equals plus and minus 3 square root of 6. And then I need to subtract 3 from both sides. When I subtract this 3, because 3 is not a like term to 3 square root of 6, I'm just going to write it in the front here. So my answer is going to be x equals negative 3 plus or minus 3 square root of 6. If you were to write those two answers separately, they would be negative 3 plus 3 square root of 6, and they would be negative 3 minus 3 square root of 6. That would be the two separate answers for the expression negative 3 plus or minus 3 square root of 6. Okay. The next two. The first step in part C, because I have a coefficient 9, would be to divide both sides by 9. I want to get my perfect square, whether it's a parenthesis or a single term, by itself first. So my perfect square, x minus 2/3 squared, is now by itself equal to 8/9. Then I take the square root of both sides. So the square root on this side, square and square root cancel off, so I just have x minus 2/3 equals plus and minus the square root of 8/9. Okay, this one doesn't need to be rationalized because I can already do the square root of 9 in the denominator. So I've got x equals, x minus, I forgot what I was writing here, x minus 2/3 equals plus and minus. I can already do the square root of 9. The square root of 9 is 3. The square root of 8 I can't do, but I can simplify because 8 can be broken down into square root of 4, square root of 2. So let's continue to simplify here. I'm going to have x minus 2/3 equals plus and minus the square root of 4 is 2 times the square root of 2 over 3. That simplifies the radical portion. Next, to get x by itself, I need to add the 2/3 to both sides. So I'm going to get x equals, add it in the front, so that's 2/3 plus or minus 2 square root of 2 over 3. That is complete as two separate fractions, but you could add them together if you wanted a single fraction. This would be then 2 plus or minus 2 square root of 2 over 3, since they already had a common denominator. Okay. Again, I'm writing both answers. You only need to give me the first answer, but sometimes your answers are going to come out as a single fraction. Sometimes they'll come out as double fractions, so you just want to make sure you can go between the two and see that they are the same. Okay. The last one, part D. There aren't any numbers to work with here, so we're going to get an expression for our answer instead of a numeric value. The perfect square is already by itself, so I just want to take the square root of both sides. So square root. That gives me bx minus d equals plus and minus square root of k. Then if I'm solving for x, I would have to add d to both sides. That would give me bx equals, added to the front, so d plus and minus the square root of k. Then again, I'm solving for x, so I would divide both sides by b. That's going to give me x equals, I can't simplify, so I have d plus or minus the square root of k over b. That is considered finished because I can't add these because they're not like terms. I can't add d and k, it's not like terms. There's no radical in the denominator, so I don't need to rationalize. Okay, let's look at the back side of this page. Example 5, the poverty threshold in dollars for an individual under 65 is given by the equation. And I want to find P of 95 first. Okay, so P of 95 is going to have me plug 95 in for T. So I'm going to have 4.95 times 95 minus 57 squared plus 1406. So grab my calculator. Type that in. So first of all, 4.95 parentheses, so times 95 minus 57 parentheses closed squared plus 1406 gives me 8,553.8. And what does it mean in this situation? So I need a sentence here. And the sentence is going to give me, this is years since 1900. So 95 years since 1900 is going to be in 1995. The poverty threshold for individuals 65 years or older was $8,555.80. So I'm just going to shortcut that. Its poverty threshold for people 65 years and older was $8,553.80. Okay. Part B. Find when poverty threshold P of T is equal to 3,000. Okay. So set my equation. 4.95 times T minus 57 squared plus 1406 equal to 3,000. My first step when I solve this is going to be to subtract the 1406, right? So it's going to give me 4.95 times T minus 57 squared equals 3,000 minus 1406 should be giving me 1594. Then I'm going to need to divide both sides by 4.95. So I've got T minus 57 now, squared, equals, I gotta get my calculator again, to do, let's check my 1594 real quick. So I've got 3,000 minus 1406, 1594, perfect, divided by 4.95, gives me approximately 322.02. Okay, now I want to take the square root of both sides. So that's T minus 57 equals plus or minus. It would be square root of 322. I can't simplify that, but because it's a story problem, we want to go decimal anyway. So we got plus or minus. Let's do the square root of that number. So I hit up and enter to bring the whole number down. So it's going to be about 17.945. Then we're going to add our 57. because these are like terms now, I've gotten rid of the radical. I'm going to separate it into the two pieces, one with the positive and one with the negative before I add. So I've got t minus 57 equals 17.945, and I've got t minus 57 equals negative 17.945. Okay, so I'm going to add 57 in both cases. The first case gives me, I need to do 57 plus 17.945. That gives me 74.945. And if I add 57 in the next case, that gives me 57 plus negative 17.945 gives me 39.055. Remembering that these are year values, and they're year values since 1900, we're going to say that in 1939, and I just put them in this order because that's the lower year, this is the higher year, and in 1974, 75, it's really close to 75, but it's maybe still at the end of December. So 1939 and 1974, the poverty threshold was $3,000. For 65 and older. There we go. Sorry about that. One page left to end this section, and we're going to be solving some more equations using the square root property. The only thing different about some of these is that the values are going to come out to be complex or imaginary in the solutions. Okay, so first one, x squared equals negative 25. X is already by itself, so we're going to square root both sides. That gives me x equals plus or minus the square root of negative 25, which we know comes out as 5i. So I have plus and minus 5i for the two solutions. Okay, and the next one, the perfect square is already by itself, so I'm ready to take the square root of both sides. It's going to give me t plus 5 equals square root of negative 64 is going to be plus and minus 8i. Here, I need to continue to solve for t, so I'm going to subtract 5 from both sides, and remembering to subtract the 5 in front of the plus or minus. So I'm going to have t equals negative 5 plus or minus 8i. Again, they need to be in true complex form, which has, this is the reason I really want to write that negative 5 in front, because true complex form has a real number, plus or minus the imaginary part. The I part needs to be at the end, which is a good habit to always add the real number to the front of your plus and your minus. Okay. Last two. Once again, perfect square is already by itself, so we're ready to take the square root immediately. So it's going to give me the 2a plus 4 equals plus and minus. The square root of negative 4 is 2i. And subtract your 4 to the front. It's going to give you 2a equals negative 4 plus and minus 2i. Divide both sides by 2 to get a by itself. So a is going to equal, I can't leave a complex form as a single fraction, but I can reduce them both by 2. So it's going to give me negative 2 plus and minus I. Right, 4 divided by 2 is 2, 2 divided by 2 is 1. Here we go. And part D, the last one, my perfect square is again by itself, so we're ready to square root both sides. This time, I've got x minus 3 equals plus and minus the square root of 32i. I can't do the square root of 32. I did the negative part, right? I knew that the square root of a negative number was going to be imaginary, but I can't do the square root of 32, so I need to separate it. So I've got x minus 3 equals plus and minus. I know that 16 goes into 32, so I'm going to separate this into square root of 16 square root of 2 times my I, and I can do the square root of 16. So x minus 3 equals plus and minus 4 times the square root of 2i. And then I can add my 3 over to get my final answer. Add it to the front, so you've got 3 plus or minus 4 square root of 2i. So those are your two solutions. Okay. On paper, it's really nice to write them together with the plus and minus. Don't forget, if you do your homework in my math lab, they're going to have you separate them to 3 plus 4 times the square root of 2i, comma, 3 minus 4 times the square root of 2i. That's what the plus and the minus mean anyway. It's okay to separate them into two, but on paper we prefer usually leaving them as one. And that's the end of part A.